started my period 2 class off like this today, and the first 2 kids I called on for what was the point at 30, they had no idea. So I said, oh, well, just look back in your notes from yesterday because it's probably plastered all throughout your notes because we wrote it down so much yesterday. Still couldn't give me an answer. And then I lost it. Okay, I had enough. All right, so I'm hoping you guys are taking decent notes and you can look back at yesterday's because the points at 30, 45, and 60 aren't going anywhere. If you're coming on today, Donovan, you're on camera the whole time, just like all your classmates are. Thank you. 30, 45, and 60. I need to know those points right away. Okay, those points right away. Okay, so I'm hoping we still have it in our notes from somewhere from yesterday. What is my point at 30 degrees on the unit circle? And it was a nice little break yesterday for you guys. I didn't call on anybody, but today that's changing big time. All right, I got to hear from a lot of you today. All right, so here we go. Bassett, we'll start with you. What's the point, Bassett, at 30 degrees on the unit circle? What, comma, what? What do you got?
Square root of 3 over 2 and 1/2.
Thank you. I didn't have to go nuts there, Bassett. Thank you. Radical 3 over 2, comma, 1/2. What is it at 45 degrees? From yesterday's notes, 45 degrees on the unit circle. What is that point? Here we go. Hi, Anna. What's that point at 45 degrees?
So radical 2 over 2 and radical 2 over 2.
Got it. Now at 60, I'm trying to help you guys out remembering this. If you know 30, you're going to know 60. All right? If you know 30, we should be able to do 60, no problem. What's the coordinate at 60 now? Here you go. Kian, what's the coordinate at 60?
1/2 and then radical 3 over 2.
Yeah. If you know 30, just flip them and you got 60. All right. Any questions on those? Because we're still using them today, tomorrow, and into next week. Those coordinates at 30, 45, and 60. All right. I got a question for you. Without going back into your notes now, would you be able to tell me the coordinate at 240 degrees? The coordinate at 240. Hopefully, just a little refresher, all you would need to find is the reference angle. That'll tell you what the coordinate should be. So I need somebody to find the reference angle at 240. Something we've been doing all unit long. The reference angle at 240. How do I find that one? Anna, going back to you. Reference angle at 240.
You subtract 180 from 240.
Yep. I got you. 60 degrees. 240 minus 180, 60. So I go to the coordinate at 60. It's the same thing. 1/2, comma, radical 3 over 2. But when you go to a different quadrant, you got to worry about what the signs are. So what do we know about the signs in the third quadrant? What should 1/2 and radical 3 be changed to in the third quadrant? Here we go. Katie, what should it be changed to?
Negatives.
Yep. Third quadrant, your x and your y's are both negatives. And there it is. There's the coordinate. Whew, nice job, guys. Feel good about that. A lot different than second period. Nice job. Any questions from you guys? That was basically yesterday. And we're going to keep using 30, 45, and 60 today. Anything you guys want to ask? All right, let's go to it then. All right, let's hop on notes 3.10. We're going to introduce sine and cosine today. Sine and cosine. At the very top of your notes, could you guys do me a favor? Because we're going to need it. SOHCAHTOA. Making sure we spell it correctly. Okay, SOHCAHTOA for me. All right, I put the unit circle back. And I've also, let me highlight it in green here, inside the unit circle, I put a right triangle for us. All right, you can still see the hypotenuse is 1, because remember on the unit circle, all the radii are 1 unit. So let's go to sine first. Let's do the sine function first. So I want to know what the value of sine of theta is here. Sine of theta. Do you see where I put the theta in the triangle right here? First thing I need from somebody, what is sine equal to as far as SOHCAHTOA goes? If you look at SOHCAHTOA, it's this over this. What is sine equal to? Here we go. Ella, what's sine equal to if you look at SOHCAHTOA?
Opposite over hypotenuse.
Good job. It's the opposite side over the hypotenuse side. So now everyone go to the triangle I put in the unit circle. Tell me the side I've labeled opposite and tell me the side I've labeled as the hypotenuse. What are on those sides? Here we go. Liz, what's the side opposite theta in that diagram?
Y.
Y, yep. And what's the hypotenuse length?
1.
1. There you go. Thank you, Liz. So the sine in this unit circle diagram is y over 1. And I want to keep going, though. You guys could simplify y over 1, right? Anything divided by 1 is just itself. So the sine of this angle is equal to that y value. And just let me finish this, and I'll bring it all together at the bottom of the page. All right, let's do the same thing for cosine now. Let's do the same thing. Come on, there we go. For the cosine of the angle. Go to SOHCAHTOA first. What's cosine equal to according to SOHCAHTOA? Here we go. Colin, what's cosine equal to?
Adjacent over hypotenuse.
Good deal, bud. Good deal. Adjacent over hypotenuse. All right, now go to the triangle in the unit circle. Go to the triangle, everybody. Anna, back to you, on fire today. What's adjacent to theta there in that diagram, Anna?
X over 1.
X, getting ahead of me there, showing off like usual. X over 1. Good job. Simplify it a little more. The cosine is equal to the x. All right, let's put this all together now. What did we just find out? Other than you just answering questions about sine and cosine for me. Here's what you just found out. That if you are on the unit circle, the sine of any angle will always be equal to the y coordinate. That's what we just showed. The sine is always equal to the y coordinate, and the cosine of the angle is always equal to the x coordinate. All right? The sine of the angle will always be whatever the x coordinate is, or the y coordinate, and the cosine will always be whatever the x coordinate is. That's all I need you guys to get out of today's lesson is sine is equal to the y coordinate, cosine is equal to the x coordinate. That's all I need you to get out, and watch how quick we can do these problems. All right, and again, I should have made note of this at the beginning, but this only works on the unit circle. I have to be on the unit circle for the x coordinate to represent cosine and the y coordinate to represent sine. All right? All right, let me show you how this works. You guys don't have to draw this at all. This is just for all of our purposes here. You don't need to draw this. All right, yesterday, we're back on the unit circle, by the way. We're back on, this is a length of 1. This is 0. This is 90, 180, and 270. Can you guys remind me? I'm going to go around and call on some people. Can you remind me what these points were on the unit circle? Look back in your notes if you need to. All right, what were those points at 0, 90, 180, and 270 yesterday? Because that's how I have to do this first problem here in exercise 1. All right, so let's start at 0. What is that red point right there? What's the coordinates for that red point at 0 degrees? Remember, it's a unit circle, 1 unit away. Ooh, go ahead, Liz. What's that coordinate? Got it from yesterday, Liz? Remember, Liz, how long? This is 1 unit, right? This point on the x-axis right here. 1, 0 from yesterday. You okay, Liz? Everyone else all right? 1, 0 from yesterday. These are the points on the x and the y-axis. So let's go up to 90 now. What was that point at 90? All right, you get redemption, Liz. Come on. Your redemption. You're hungry for this. You wanted this. What's it going to be at 90?
I just don't know how to do this.
Okay, here you go, Liz. Ready? You're on the XY axes right now. Okay? I got this point, this point, this point, and this point. And remember, since we're on the unit circle, it only goes out to 1. It only goes up to 1. It goes out to -1 here, and it goes out to down to -1 here. So what I'm basically asking you for is, if I asked you to graph that point right there, it would be 1, 0. If I asked you to graph this point here where 90 is, how would you name that point? That's what, comma, what? On the y-axis right here at 1, what is that point? That's what I'm asking for.
0, 1.
There you go. All right, 0, 1. Everyone else all right? 0, 1? Okay, what about at 180 now? What's that point at 180? Anna?
-1, 0.
-1, 0. And then how about at 270, everybody? You want it, Liz, or no?
No.
No? Just going down to -1 now.
0, -1.
Okay. You're fine. Everyone else, how we doing here? This, again, the little review from yesterday. At 90, 180, 270, those are the points on the unit circle again. Everyone all right before I tackle the chart here? All right, let's put this all together, hopefully. Everyone look at 90 degrees. 90 degrees. It's 0, 1 at 90 degrees. I'm looking for the sine of 90 right now. Sine of 90. And we just went over on top which coordinate represents the sine. Is it the x or is it the y coordinate that represents the sine? Here we go, Hunter. The x or the y that represents the sine?
The Y.
The y. So, Hunter, at a 0, 1, which one's the y coordinate?
1.
1. So, everyone, the sine of 90 is 1. I got that by going to 90 degrees and taking the y coordinate. Cosine is what coordinate? Anna, cosine is what coordinate?
The x coordinate,
Which is what at 90?
0.
So the cosine of 90 is 0. Everyone's seeing how we're using this now. The sine is the y coordinate of whatever degree I'm at, and the cosine is the x coordinate of whatever degree I'm at. So let's go to 180 now. Hunter, back to you. What's the sine is what coordinate again?
Y.
The y. Go to 180, Hunter. What's the y coordinate at 180?
0.
So the sine is 180, everybody, 0. See how I'm using these points to find the sine and cosine of each angle. Shoom, here we go. Colin, cosine is what coordinate? Cosine is the what coordinate?
X.
X. So go to 180, Colin. What's the x coordinate at 180 degrees?
-1.
There you go, guys. Cosine of 180 is equal to -1. Are we okay? I'm picking this up. All right, everyone go to 270 now. Just tell me, what's the sine of 270? I won't even ask what coordinate anymore. Sine of 270. Hunter, going to you. The sine master here. Sine of 270.
-1.
He's picking off the y coordinate because sine's equal to y. Cosine of 270. Here we go, Eliana, cosine of 270. Not on, okay. Here we go, Liz, cosine of 270.
Zero.
Done, x coordinate. All right, whoa, hey guys, 360? I don't have 360 on my diagram, but I could use what instead? I don't have 360, but it's the same spot as 0, yep. 0 and 360, same spot. All right, so what's the sine of 360 then? Sine of 360. Here we go, Donovan, sine of 360.
0.
0, it's the y coordinate, everybody. Sine of 360, 0, the y coordinate. How about cosine of 360? Here we go, Mason, cosine of 360.
1.
1, the x coordinate. Everyone good? How we're using the x and the y coordinate now to find sine and cosine. I just need to know what the coordinates are at every spot. If you know the coordinate, you just pick off the x and the y. All good? All right, now we got to answer parts A, B, and C. All right, let's go to part A. Oh, you guys remember this from last year, I hope. Find the numerical value of f of pi for the given function. All right, so all it's asking us is, instead of having an x, plug in a pi for me. Instead of having an x, plug in a pi. So I'm asking, what's the sine of 2 pi? What is the sine of 2 pi? Whoa, that's in radians. Anybody yesterday? 2 pi, 2 pi. What's that convert into degrees quickly? So I don't have to use my reference sheet. 2 pi is what in degrees?
360.
Sine, yep, good, you're hungry. Sine of 360, same thing. All right, you guys can use your chart. You can pick off the y value at 360. I don't care what you do. What is the sine of 360? The y coordinate at 360. There you go, Ella, what do I have?
0.
0. So the answer to that one is 0. B. Cosine. Pi over 2? Pi over 2, that's radians. Anybody? Pi over 2 in degrees? Boom, boom. Pi over 2, boom. We wrote them down yesterday. What do we got?
90.
90. Cosine of 90 plus 2 times the sine of 0. All right, look at your chart. Look at the unit circle if you need to. The x coordinate at 90. X coordinate at 90. Let's roll. 6. Woo, Mason. What's the cosine of 90? You can use your chart or the x coordinate at 90.
1.
1.
Right, the x at 90.
Yo, x at 90. Look at that point at 90. 90 is 0, comma 1.
Oh, so 0.
0, yep. Cosine of 90 is 0 plus 2 times, somebody help me out. What's the sine at 0 degrees? The sine at 0 degrees. Think about what coordinate you need. The sine at 0 degrees. Boom, here we go. Will, the sine of 0.
0.
0. So 2 times 0 here. And you guys can do that math pretty quick, right? 0 plus 2 times 0. I get another answer of 0. All right, one more. -2 cosine 180. Let's start right there. Cosine of 180. So go to 180. What's the x coordinate at 180? Caroline, hello. Cosine of 180.
-1.
So -2 times -1 plus 3 times, guys, sine of 270 now. Go to the y. What? Yeah, settle down. You always get a little too out of control here. Sophia, there we go. Sine of 270, Sophia. The y coordinate at 270.
-1.
Yeah. All right, guys, so what do I have there? 2 minus 3. So -1 for that one. Man, you guys got some power now. All you need to know is the point at that degree measure, and you know the x is the cosine and the sine is the y. We just did it for 90, 180, and 270. What do you say we do it for 30, 45, and 60 instead? First thing, this is the first time this year we've seen this term in the directions, exact value. Can you please jot this down, what exact value means? And what am I expecting from your answer when it says exact value in the directions? Here's what I'm expecting. Answer should be fraction or radical. All right, fraction or radical. That's what if you see exact value in the directions, your answer should be in the form of a fraction or a radical. What is not up there? A long, sloppy decimal. That's what I do not want, all right, as the final answer. I do not want a decimal ever, just a fraction or a radical. All right, sine of 30. Sine of 30. All right, so the first thing we need to do is go to 30 degrees in the unit circle. Maybe you remember it, maybe you don't. Go back and look. What is the coordinate at 30 degrees on the unit circle? Here we go, Mason. What's the coordinate at 30 degrees on the unit circle?
So well, I'm going back to where we had it. Way back. It was pi over 6.
Well, I know you weren't here yet. That's not what I'm asking for. On the unit, here you go. I got it up on the screen here. 30 degrees. You see the point here I have at 30?
1/2.
At 30 degrees, radical 3 over 2, comma 1/2. All right.
Okay.
You might highly recommend getting those notes from yesterday, all right, when you have the opportunity.
Yeah.
Because it bleeds into today and the rest of the unit. Radical 3 over 2, 1/2 is the point at 30. But I'm asking for the sine. So put these two together right now, yesterday and today. If I'm asking for the sine, you need which coordinate now? Nick, first time today. What coordinate, Nick, do I need if I'm looking for the sine?
The y.
The y, which is what here?
1/2.
So the sine of 30 is equal to 1/2. Done. I just needed to remember the y coordinate is sine, cosine is x. All right, let's go to 45. Find the exact value of sine of 45. Well, first thing I need is, what's the coordinate at 45? So I can pick the right one, and you guys will figure out it doesn't matter which one you pick, but. Colin, what's the coordinate at 45 degrees on my unit circle?
Radical 2 over 2, radical 2 over 2.
Good job. Those are the guys, this is the only three you need, 30, 45, and 60. All right, it doesn't matter here, but I'm still going to ask it. What coordinate do you need if I need the sine now? What coordinate are you going to pick off? Go ahead, Anna. What coordinate do I need if I'm looking for the sine of anything?
Y.
The y coordinate. So I'm just going to pick off radical 2 over 2. Everyone okay so far? And then finally, cosine of 30. Cosine of 30. Even though it's already up on the screen and up on your notes already, I'm still going to ask somebody, what is the coordinate at 30 degrees on the unit circle? Bassett, what's the coordinate at 30? This is how you started the day today.
Square root 3 over 2.
Comma. I just want the full coordinate first.
Oh, square root of 3 half and then 1/2.
Good job, yep. And you guys are finding cosine of that. So I need which coordinate if I'm finding cosine? Will, which coordinate do I always use if I'm looking for cosine?
Probably X.
X, good, which in this case is radical 3 over 2 for me. Everyone all right on how we're using yesterday and today now? All right, something a little different to end the day with, this multiple choice question. I got a terminal ray of an angle. By the way, if anybody wants to know here, I don't know, this is like our fourth Greek letter we've learned today. Alpha. Alpha, if you're wondering. We had alpha, beta, theta. I feel like there was one more. Maybe this is our third one. All right. Sigma. Oh, thank you. Thank you, Caroline. Thank you. Sigma. So there is 4. Okay, it goes through this point. All right, it goes on this point. It goes through negative 0.6, 0.8. And here's the huge part. That point's on the unit circle. If I see any points on the unit circle, I'm automatically thinking, hey, that X is the cosine and that Y is the sine. All right, if any point is on the unit circle, I know the X coordinate represents cosine, the Y is the sine. And look at my question. Which of the following gives you the value of the sine of alpha? Which gives you the value of sine of alpha? And it's already on the unit circle for you. So out of those 2 points, which one are you going to pick off? Woo, here we go. Katie, which one do you pick off if I'm looking for the sine?
0.8.
Because that's what coordinate, the X or the Y?
The Y.
There you go. We're not, guys, I'm not trying to get complicated with you. It's just I got to have you remember X is cosine and Y is sine if woo, excuse me, if you're on the unit circle. Going too fast for myself. All right? Last thing at the bottom before you start the assignment, which you'll probably start and finish at the same before class ends. Make a little note here for me. I have a question for you, and this is the toughest question I'm going to ask today. On the unit circle, what is the highest number on the unit circle as far as coordinates go? As far as coordinates go, what is the largest number on the unit circle as far as the coordinates go? It only goes up to what number is the biggest? And I won't even call on anybody. If anybody thinks they want to chime in, go ahead. The highest coordinate, the largest coordinate on the unit circle. It only goes up to as high as what?
1.
Yes. Where do we have that? Who chimed in there?
Me.
Colin, you?
Yeah.
Good job, boss. Nice job. Yes, it only goes up to 1. Does anybody see a 2, a 3, a 4 on that unit circle? No. It only goes up to 1. And I mentioned that so you guys can just jot down then. If 1 is as high as it can go, sine and cosine are never bigger than 1. Okay? You should not ever give me, Mr. Carlino, the sine of that angle is 2.5. No. A sine or a cosine can never be bigger than 1. Why? Colin just told us no coordinate is higher than 1. No X or Y coordinates bigger than 1. All right? That'll help you out on one of the problems you're going to do in a couple minutes. All right, everyone open up Classroom if it's not open up already. Go ahead, open up Classroom. Go to Unit 3 for me. Scroll down to Unit 3. Everyone open up week of November 2nd homework answers. Open up that file. Look for November 5th. And check your answers as you go along. Go ahead. You guys can get started. Open up November 5th. At the top on page 25, you may want to write x equals cosine, y equals sine, just to remind you at the top of your page on 25. If you can remember it without writing it on top, no problem. If you can't answer one of them, let me know. I'll help you out. We should have an issue here getting it done in the next 11 minutes.